Welcome back to some continued learning in some various machine learning techniques. We did an introduction recently to kind of go over an overview of how to kind of try to do some predictions with the data and various ways to do that. A lot of times the technique that needs to be used is very heavily weighted on the problem you're trying to solve, also what type of data you have, and whether the result or the item you're trying to predict is something that's numeric, some sort of a numeric outcome or a probability, or it could be also trying to predict a classification or just something that would be a unique category, so to speak. You could be trying to predict true or false. You could try to predict with the iris data set, maybe based on the length or the width of the plant stem, try to predict what the species is. That's more of a classification problem. So as we explore some of the various techniques and types, this lecture is going to cover a clustering. So this should be somewhat familiar. In a prior lesson, when we were trying to use R to solve a business problem, k-means was a technique that was used throughout there. And during that lecture, I kind of talked through what it did, but not exactly how it did it, and kind of went quickly through the actual k-means algorithm and just kind of showed how it was useful and some of the benefit that you can gain from that and using that for business knowledge, but wasn't a very deep dive into how it was used. And so now this is a part of the class structure where we can kind of dig deep into what's going on behind the scenes with a k-means clustering. And so what I thought I would do is I pulled virtually the same script that was used for that lecture. I cut it down to be more specific to this, and I have some examples of the baseline, and then we can do k-means clustering for 2 clusters and for 3, and we can visualize it, and I'll talk through that as we go. So let's go ahead and get started here. To start with, loading in libraries. These are just common libraries that are going to accomplish this set of code. ggplot2, of course, for visualization. dplyr is all the manipulation. I'm pulling in zip code because for this analysis, I'm actually using latitude and longitude points, so we need some zip code data set through there. Our color is just to aid some of the visualizing and the coloring going on, and geosphere is to help with some of the latitude longitude points here. So with this script, as I kind of walk through here, I've covered some of this in the past, but scientific notation, we can turn that off, is something that this line here is doing with these options. Setting the seed is something I believe I've covered in the past. Anytime we have some random numbers or some sampling, setting the seed is something that allows that to be repeatable. So just by setting some sort of a set of numbers here, if someone else were to run the same random functions or try to get some random variables, they will stay consistent according to whatever numbers you put in there. So I just picked 4 numbers and put them in there. Okay, so reading in our data set, this is straight from the state of New York that publishes lots of different data sets, and we'll go ahead and view this, and I'll show off what this is, because the problem that we were trying to solve in a prior lecture that I'm going to talk through here is these are just store locations. So we had a fictitious company that had a lot of deliveries they wanted to make, and we have a lot of latitude and longitude, within New York, different cities, different specific locations based on latitude and longitude. And how this is useful for clustering is essentially every single unique location, every unique latitude and longitude point would get a dot in a kind of a cluster diagram, and we can use the k-means clustering to determine optimal shipping points, where you might want to deliver a truckload of product, and then of course some smaller deliveries from there, almost like a distribution center or a distribution network using k-means clustering. So that's kind of the problem here, and let's go ahead and walk through how this works behind the scenes. So one thing here with the zip code data, I'll just go ahead and kind of run this all at once, because this is just a set of updates that will kind of do some merging, and it'll take our original data set and link it up to the zip code data, and then based on the zip codes, we can pull in latitude and longitude properly. It'll clean it, and it just makes things work a lot easier. So that's all that those lines of code are. So all right, so let's dive right into the actual k-means here.